So we saw OSPF as a very good link state routing protocol, and we also saw in a LAN environment,
Mm-hmm.
it sends the hello packets every 10 seconds.
Mm-hmm. Yeah.
And in a WAN environment, it
What time?
is
Mm-hmm.
30 seconds. No,
Mm-hmm.
I'm talking about hello.
Okay, okay.
Death timer is 40 seconds, 120 seconds
Mm-hmm.
in WAN. This is in WAN, this is in LAN. Hello
Yes.
and death timer.
Mm-hmm.
This is 40, 4 times of 40 is 120. Sorry, 3 times of 40 is 120. This is 10, 3 times of 10. Hey, come on, sir. Sorry, I'm wrong. This is 40.
40, yeah. 4 times.
4 times of hello is what death timer. So
Mm-hmm.
4 fours are 4 threes are
No,
12.
yeah.
Then it is 30, sir.
330,
Okay,
yes.
30. 4 threes are 12. Okay. 4 threes are 18. No, 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 no. Oh, come on. Now what am I doing? 180, sir. 180. 180. Yeah? 180.
Mm-hmm. Mm-hmm.
So 10 and 40 in 10 in LAN and 40 in WAN. Sorry. Okay, I know where I made the mistake. In LAN, hello is 10, dead timer is 40.
Yeah, correct.
In WAN, hello is 30, 4 times of hello, 4 threes are 12,
Yes.
120. That's correct.
Okay.
So it was
Mm-hmm.
correct. I
Mm-hmm.
just put this number here and this number here. That was the mistake.
Yes, yes.
So now, whether it is sent every 10 second or 30 second, they always carry certain parameters. And if the parameters matches only then, the neighbors will be
Mm-hmm.
joining. Neighbor
Correct.
will be established.
Mm-hmm.
So about the parameters, we'll see in the next chapter. Now, OSPF forming adjacency. Adjacency means what? Neighborship. Is
Neighborship.
neighborship and
Mm-hmm.
adjacency same? Slightly different. You see, neighborship is
Mm-hmm.
you can have thick friend, you can also have just friend, isn't it?
Mm-hmm. Yeah. Yes.
But you simply call it as friend only.
Mm-hmm.
Uh, he's my friend. You see, your friend, he took 10 lakh rupee and he did not give. No, 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 no. He's not a real friend. I know him, that's all. We immediately change,
Mm-hmm.
no? We are not thick friends. I know him. He was in that college. I know him. That's all I
Mm-hmm.
know him. Please don't ask about his money to me. If he has cheated
Mm-hmm.
10 lakh rupee, don't please ask me because I don't know his house. I don't know his mother. I don't know his father. I don't know his family. I don't know anything about him. I just know him in college. That's why I said he's my friend. But he's not real thick friend. But we give the same
Mm-hmm.
word, no, friend.
Mm-hmm.
Whether he's thick friend or thin friend, we give the word friend. We don't go in detail. Only if there is any problem, we go in detail. Correct?
Yeah.
Likewise. If you form thick friendship, it's called full adjacency.
Mm-hmm.
Full adjacency. Thick friendship. Full adjacency. If you simply know each other,
Mm-hmm.
he was in that college. I know him. Yeah, he was my senior. His name is
Mm-hmm.
Jayachandran. Then
Mm-hmm.
it is only two way. I
Mm-hmm.
know his name. I know he was doing. I think BSc Physics. That's all I know. I do not know his native place. I do not know anything about him other than his degree and the year he studied in my college. It is just a two-way
Mm-hmm.
street.
Mm-hmm.
So there are two type of relationship OSPF establishes. In point-to-point environment, it will form full adjacency, meaning it will form thick friendship. In point to point, it will form thick friendship, full adjacency. Whereas in multi-point, LAN is called as multi-point. Why? It's not just two router. This is point to point. LAN means what? You
Yeah.
have many routers. When you have many routers, there will be one router elected as a designated router. Another router will be elected as backup designated router. Only with this router, everyone will form full relationship, full neighbor. What about between these two? They will only have two-way.
Got it.
See, that is what called as other routers. Only with the DR and BDR, they have full adjacency. Between other routers, they will have only two-way relationship.
Two-way relationship. Okay.
What does that mean by full adjacency? The LSDB, everything is shared and they are fully synchronized. That is called full adjacency. Thick friend means what? I know what he will do. If you tell him, he is going to kill you. I know him very well. That is what called as full adjacency. I know about your father. If your father knows this thing, he's going to kill you. Which means wife knows husband very well. He will get angry. But you cannot say that to other friends. We don't know how they will behave because we don't know much. So full adjacency means sharing all the database and fully synchronizing. That is what called as full adjacency. In two-way, they don't share database. Two-way friendship means what? He know my name, I know his name. That's all we know. We don't share anything. We don't share our personal matters. He don't share his personal matters. So we don't have full adjacency. He's not my thick friend. We are just two-way relationship. Yeah, I know him. He was there. That's all. You understand? So only with the DR, this synchronization happens. That is what called as adjacency. Full adjacency. But between the others, there is no adjacency, only neighbor. Just neighbor.
Neighbor, yes.
Just neighbor. We know about this, how the best route is elected. How the best route is elected. We already know that the link state database is formed by advertising, link state advertisement, isn't it? After that, the SPF algorithm will be running on the database, LSDB.
LSDB.
Right. And then for every route, it will pick the best path from the tree. Tree means what, from here to... This looks like tree, you see. From here to go here, if I come this way, 1, 2. But if I come this way, 1, 2, 3. So which is the best way? Going via A is not the best way. Going via D is the best way, isn't it? That is what here. Each router, the area place itself in the root of the tree, and it will build the best path for every destination. And the best path will be placed inside the forwarding database called routing table. It's a known story, correct? So did you understand this picture now? Assume that each link is 10 cost. If one link is 10, this is 10, this is 10, this is 10. Each link is 10. So if X needs to go to G, take this path, which is only 20. Take this path, 10 plus 10, only 20. Instead, if you take the other path, it is 10 plus 10, 20 plus 30, it will be too long.
Plus.
So this is how the binary tree algorithm, Dijkstra's algorithm, SPF algorithm calculates. Yeah. Now you see this page. I just want you to take 2 minutes or 1 minute. Read yourself. I'm going to explain this. Wait. There's a router.
Sequence number I didn't get. Maybe.
There is a router. Now this LSU is coming. What is LSU? Many LSA together called as LSU. Link state update. One update is coming. When update comes, it will come with some sequence number. Let's say it is coming with sequence number 10. Now the router is receiving it. First, router will see whether I have anything in my database. If it is a fresh router, there won't be anything, right? There is nothing in my database. So what I should do, whatever comes in, I have to add it to the database. And then I need to send the acknowledgement to the sender, isn't it? After that, I'll send my database to my downstream, my neighbor, my down neighbor. After that, I'll use my SPF algorithm like what you saw in the previous page, and I calculate the best route, I put it in the routing table. Is this clear? Okay.
Yes, this is clear.
What if it is no? If means, it is checking is my database having any entry. When it is no only, we saw what will happen. What if I already have some entry? Then it will check whether the already known sequence number and this 10 is same. If it is same, do I need to learn it? No need. I already know it. I'll ignore it. So is this clear?
No.
Okay. Now, what if it is not same?
Yeah, it's clear.
If it is not same, it will check whether what I am receiving is higher. If I am receiving higher, what I already have is, let's say, 9. What I'm receiving is latest one because coming is 10. So what should I do? I need to add it to my database.
10.
That is what it says. Go to A.
Database.
Is this clear? Now, what if I already have 11? What is coming is small, which means I am already updated.
10.
Mine is not. Mine is higher. What is coming is not higher. So I need to tell my source. I need to tell to my sender, what is that? You are not having the latest one. I am sending you the latest one. You see? I am sending the newer information to you. It is sending to the source. Source, you are not updated. I got the better one. Take this. Is this clear? One more minute. I'm giving you. Go through this.
Yes.
Same thing. Same page. I want you to go through this.
Same page? Okay.
Okay.
Yes, I want to it. Yes.
Now, see, even though as soon as the change happens, the changes are sent triggeredly. Triggered means immediately. Just to make sure that everyone is up to the date, it will also send every 30 minutes the complete database, so that no one will miss anything. You understood? So OSPF follows hierarchical design so that it can be easily manageable. You can do summarization, all the stuff. These are the things that we learned. Okay. So in our next chapter, we will be learning how to configure